True or false? And remember on the worksheet, remember there was a code red? I'll tell you right now, code red is on tomorrow's test. So if you don't know how to do that, well, let's do it after 4. Did you say by coming to Ilani you're going to do it every day? Further questions? Okay, now tomorrow, there's three problems. Number. You guys are so funny. Oh, that's not even funny. Did I or did I not do as an example 2 to the x minus 1 over x? So I make 3 to the x minus. But I don't care. I'm going to do it anyway. Now, tomorrow, you better make sure you can use L'Hopital's rule. Can I use it here? Do I get 0 over 0 or infinity over infinity? If I plug in 0 for x, is it 0 over 0 or infinity? Because if it's not, you cannot use L'Hopital's rule, which would result in a fatal error. So yes or no? Yes. Okay, so what does L'Hopital's rule say? And if I don't see the limit on every step, I'm going to go crazy. What's the derivative of the top? Look, I can do this in my sleep. You got to do it when you're awake. All over, what's the derivative of the bottom? 1. Now can I plug in 0?
Yes.
Yeah, natural log 3. I'm going to make it with a 2 there, so that's what's natural log 2. You guys don't feel ashamed?
No.
Obviously not, because it just keeps on going throughout the whole year. Next approach is 0. Yeah? This is AP, you're still getting 5.0 for an A, you know. Can I use L'Hopital's rule?
Yes.
So some of you are just using it indiscriminately a bit. Trap you.
Yes, you can.
I'm going to trap you like a rabid Wolverine. Rabid raccoon. Can I use L'Hopital's rule?
Yes.
Yes, because if you plug in 0, you get 0 over 0. That's when you know you can use it. Okay, so I'll do the top one. 1 minus cosine x. Okay, who's doing the bottom? Wait, Lum's not here tomorrow. So you use the product rule. Do not use tabular. Product rule. Okay, now what happens when I plug in 0? It's still 0 over 0. So you do L'Hopital's rule again, which means you need to write another limit. Teruya?
You did?
I don't know if you wrote limit on every step. That's what I
Do
thought.
we have to?
You don't have to do anything. Okay, take the derivative of the top. Now be careful now, the derivative of 1 is 0, because I remember last year they put in 1 as the derivative of 1. What's the derivative of negative cosine x? Positive sine x. All over, now the bottom, this one is just cosine x. And over here, you got to use the product rule. So derivative of the first, leave the second one alone. The first times the derivative of the second, which is negative. Now can I plug in 0 and get something?
Yes.
Yes, you get 0 over 2.
0.
0. L'Hopital's rule is not hard, right? You just got to take a derivative, man. That's the problem, is the part. Anyway, have all the fun you want right now, because when you come back, remember I told you, quiz every day. You don't do your homework, you come after school. Because if you don't do your homework, you're going to be kicked out of class. So you're going to miss the quiz and the lesson, so you got to come after school to make up the quiz and the stuff you missed. People only do it once, after once they don't do it again. Why am I? I'm just looking at that side of the room. Okay, can I use L'Hopital's rule? Yes or no?
Yes.
Okay. Derivative of the top, 9 minus And is the derivative of sine 3x just cosine 3x?
No.
No, you gotta multiply by derivative of box. So you multiply by 3, so there's gonna be a 9 there, right? You don't want to multiply by derivative of the box, you get in trouble. How can I plug in 0 and get something? Nope, it's still 0 over 0. So you L'Hopital it again. So the top, that's 0. What's the derivative of negative cosine 3x? Is it just sine 3x? No, because I left the space. So you times it by 3, there's 27 there. Is that why you got it wrong? You guys forgetting to multiply by derivative of box? 30x. Still 0 over 0, so you L'Hopital it one more time. So what's the derivative of the top? Cosine 3x times 3, so that's going to be 81. And the derivative of that is simply 30. Now can I plug in 0? Yes, because cosine 0 is 1. So basically just got 81 over 30, which can be reduced to
27 over 10.
27 tenths. That's a good one because you got to L'Hopital it 3 times. Yeah. You don't have to do anything. I don't, just get it right.
Okay.
L'Hopital's rule is so simple.
So as long as we
In
get
fact, some of you might go, hey, this is friend, that's tree, and then you finished already, right?
So as long as we get the right answer, it doesn't matter.
Right? Some of you go, hey, that's friend, that's tree.
Mr. Park.
Okay, but then I guess we don't know what you're talking about, so just keep L'Hopital like that, yeah.
So as long as we get the right answer, it doesn't matter what.
Yeah, I'm pretty much just gonna look at your answer.
Okay.
Unless you're certain you're like a suspected target. Unless you're under investigation, then I'm gonna go through the fine
Frosty
comb.
Day-Day.
Wakahiro.
Frosty Day-Day.
No, come on, she built up a reputation.
She doesn't have her.
X minus tan inverse x over x cubed. Can I use L'Hopital's rule?
Yes.
Wait, are we even doing this one?
Yeah.
Well, yeah, but you guys could do 13 and 14, that's so strange.
Wait, 13 and 14 wasn't that?
L'Hopital's
I
rule,
know,
okay.
but I did.
I'll do the bottom, 3x squared. Who's doing the top? You raise your hand, you know I'm not gonna call on you.
Yes.
Wakahiro, redeem yourself.
Spike the game, Mr. Park.
1.
Half his paper.
Now can I plug in 0 and get something?
No.
Nope. Still 0 over 0. So I'm going to use L'Hopital's rule again. I'll do the bottom, 6x. Who's top? Lynn! I didn't quite hear that atrocity again. Okay, that's 0. Okay. What did you say over here? 0 over 0 plus 2x. Is that what you said? I think that's what you said. Let's replay the video. So to take the derivative of a quotient, just take the derivative of the top and the bottom separately. No, it's called the quotient rule.
Or it's called.
Or you can do something else, but you can't do something like that. Now? Okay, I said quotient. If you see a quotient, you use the quotient rule. Minus high, d low, all over denominator squared we go. Or you can think of this as negative 1 plus x squared to the negative 1 power, and then you can use the power rule. Box to the negative 1, in other words.
Yeah.
So would you rather use the quotient rule or box to the negative 1?
To the numero.
Okay, Lau, finish it. Okay, let me put the 0 from Lyndon. 0. Box to the negative 1. Come on, man. Or in the front.
So plus
What?
1 plus times 2x.
How do you take the derivative of box to the 4? 4 box times the derivative of box? No,
Yeah.
4 box cubed times the derivative of box. This is the chain rule, people.
To the negative 2.
These are like a black cat in a dark room looking for a dark man. Stab in the back.
That's racist. We're recording. We're recording the racism.
So what is the power?
Negative 2.
-2.
I-
Come on, man. Even Pancho can do the chain rule.
Not even there.
Okay, now can I plug in 0?
It's like step in the back.
So
Yes.
it will be tall again?
No.
No! Come on, cancel out the x's.
Yes.
Yeah, if you want, okay, no.
We
You want to
finally
go
knew
up
it.
and down, you can, but then you gotta use product rule. But within the product rule, you're gonna have to use the chain rule. Why not just cancel the x's and be done with it?
And it's more fun that way.
Okay, you wanna go one more? I'll do it if you want.
No.
Okay, and then look, 2 goes into 6 3 times. What happens when I plug in 0 for x?
1/3.
1/3.
Wait, where did how'd you get box?
Let's look on the derivative sheet. How do you take the derivative of box to the n power? Is it just n box to the n minus 1? No, times the derivative of box. Box, there, box to the -1 power. You put the power in the front, that's why it becomes plus. You make the power 1 smaller, and then you multiply by the derivative of box.
The derivative of tan inverse x.
Okay, what is the number 1 derivative on the list? The one on the very top? This one right here. No, they're all chain rule. They're all the chain rule. But this is the first one on the list.
D over dx.
The
u to the x
derivative
equals n
of
times
u to the n is equal to this. Now the next thing, Mr. Park, what does this symbol mean?
The
This means take the derivative with respect to x. That's what it means. Okay, now, L'Hopital's rule is very easy if you know how to take derivatives. But I guess that's the problem, yeah? And I don't even have to sign inverse 1. Oh, that's because I'm saving down for the
Oh, right.
okay,
It's not on
kid,
paper.
you better know the derivative of sine inverse tomorrow. In fact, why don't we just do it for funsies then?
That's wrong.
Example, what is the limit? X approaches 0. X minus sine inverse x over x cubed. It kind of looks like that one. Okay, what if I change the tan inverse to sine inverse? Oh, hell.
Yeah, pretty much.
Okay, let's just try it for funsies. Well, can I use L'Hopital's rule?
Yes.
Okay, I'll do the bottom. 3x squared. Who's doing the top? Hurry! 1. Good. Did everybody remember that's the derivative of sine inverse? Because 0 over 0. X on the bottom. I'll do the 0. How do I take the derivative of that, which is very similar to that one? Okay, who's up over here? Who's up? Louis.
Which one?
There's more than one Louis?
Oh, wait, no,
Okay, Louis. 1 plus x squared?
Oh, minus 1.
Oh, phone a friend, phone a friend.
Let's look at this right here.
Phone a friend.
We cannot even take the derivative of u to the n. You put the power in the front and you make the power 1 smaller. Okay, see, look, why don't you change this to 1 minus x squared to the -1/2? So if I put the -1/2 in the front, what happens? Put the -1/2 in the front.
Positive half.
That becomes +1/2. Make the power 1 smaller. Then you multiply by the derivative of box, which is x. You're getting confused with antiderivative, right?
Yeah.
Does everybody see that?
Yes.
Oh, the 2 cancels the 2.
So it's negative.
The x cancels the x. Now can I plug in 0 and get something?
Yes.
1/6. Negative. Don't forget the negative sign there. So what would happen if this was on tomorrow's test?
I'll have it.
-6. 94 is a darn good score. Okay, we better practice code red. You guys understand code red? Okay, if you are given the velocity, see look, okay look. If you are given the velocity, like say something you know how to take the answer, like t squared. Okay? Plus t. No. Here, let's make it simple. Yeah. Squared plus 2t plus 1. Yeah, I like that. X of 1 equals, give me a number.
7.
7. X of 5 equals 1. Okay. Do I need to use code red on this problem?
Yes.
No. Because you know how to find the antiderivative of this. If this is the velocity, how do you find position? You find the antiderivative, right? What's the antiderivative of this? Cubed squared
That's t.
plus t plus a constant, right? How do I figure out the constant?
Don't need to.
You need to know the initial condition right here. X of 1 equals 7. So if I plug in 1 for t, x comes out to 7. So 7 equals 1 plus 1 plus 1 plus c. What is c?
4.
4. So we know c is 4. So how do I find x of 5 now? You just plug in 5, and there's your answer. But that's because you could find the antiderivative. We use code red when you can't find the antiderivative. You guys remember that when you take antiderivative, you need to put plus c?
Yes.
Okay, so what if I do, okay, same thing, except now the velocity is, okay, I'll give you something where you can't find the antiderivative. Sine t squared. Some of you think you can find the antiderivative, but you can't. Just believe me, you can't. You can't. Okay? So, if x of 1 equals 7, how do I, oh, that's not even x of 1. If x of 1 equals 7, what is x of 5? Do you see the difference between these two problems? This one, you can't find the antiderivative, it's easy. This one, you cannot find the antiderivative. So this is where you do code red. So what do I do? I'm going to integrate the velocity from 1 to 5. Now, how do I get these numbers here? Because these two, one of them I know and one of them I'm trying to find. Now, what is this equal to according to the fundamental theorem of calculus part 2? How do you compute integral? You find the antiderivative of the velocity, which is x. Plug in the top number, plug in the bottom number, subtract. So isn't this equal to x of 5? Fundamental theorem of calculus part 2. Like the most important theorem in the whole class. Okay? So, can't you do this on your calculator? You can math 9 this on your calculator, right? So this number you know on your calculator. We know x of 1 is 7. So how do I compute this? Yeah, you just add 7 to this answer, the thing you get on your calculator. Yep. So compute that on your calculator, add 7, and that's the answer. This is code red. This is on tomorrow's test. I already made the test. First one.
Yeah.
Didn't we discuss it already? Okay, let's do it. And if you need extra practice, then do this one over here, right? Okay, which one? 2C. We didn't do 2C? Okay, 2. R is the region by, hey, remember trying this on the board. Y equal natural log x, woo, and y equal x squared, x minus 3l, woo. Okay, so you already computed the points of intersection already, right? Okay, why wouldn't you just call them A and B already? this about the line x equals 4. So x equals 4 is over here, right? Because this is like less than 4 at this point, right? Line x equals 4. If I make a rectangle, see, I was looking at you guys' papers. So some people don't even have the picture of the thing on your paper, let alone the rectangle. I don't know how you guys can figure out what it's going to be. If this rectangle goes around this line, is that a disc, shell, wash, or what?
Shell.
It's a shell. So the formula for a shell is 2 pi radius height dx, since the rectangle is vertical. So this is the radius of the shell. What is that distance? Or minus x. Because when you label this point xy, that means this is x. But from here to here is 4. So if this is 4 and that's x, what's that? That's 4 minus x. The height of the shell is always the length of the rectangle, so that's going to be y1 minus y2, well, assuming you call y1 ln x and y2 the other one. Then you add them all up from, it'll be, I'll just punch it in the calculator. Okay, I'll just tell you, number 1 on tomorrow's test is like number 2 right there. All 4 parts right there. Number 6. Okay, this I'll tell you right now, this problem is on tomorrow's test. The rate at which water is pumped into a tank is given by this. This is the rate of the water being pumped into the tank. So how do you find how much water got pumped out from during the first 10 minutes? Just integrate it from 0 to 10. Don't forget the dx for 1 point. That dx is 1 point on every problem. So tomorrow, all I want to see is I want to see the integral, and then I want to see the answer. That's all I want to see. Some people are writing like what you type in your calculator. I don't want to see that. And neither do they on the AP exam. They just want to see the integral and the answer. 3 points, 3 points. But if you don't get that, it'll be minus 6. Unless you're off by just like a constant or something. Because some people do some weird things, like they put a pi just for fun. I don't know why you put pi. Okay, so all of these problems are there, cutting the area into red. Everybody know the difference between total distance traveled and net displacement? But here, I'll make it easy for you. So if you were a teacher and you only have room for 1 problem, which one are you going to put? You're going to give the net displacement or the total distance traveled? Yeah, you're going to put total distance traveled, right? Because most people, okay, if you're given the velocity, then most people would just do this, right? But that's net displacement. If you want total distance traveled, you've got to put the absolute value on that velocity.
So now that you told us that, you're just going to put it.
Oh, I'll make it easy for you. Total distance traveled is tomorrow. So if I don't see that absolute value there, I'm going to take a double. Minus 12.
Take a
Double. I'm telling you today. You too, if you're watching on the video, Wang and Samao and Suzaki. Suzaki, this is probably you right there. Okay, I'm trying to remember, and then the last 3 problems are L'Hopital's rule. That's the whole test.
Cool.
I think it should be pretty easy. Yes. This.
Most likely the spark's going to be average.
Oh, what about average value? Everybody knows that formula for average value?
Yeah.
1 over b minus a, integral from a to b of f of x dx. Okay, look at number 3 then, since some of you are, what? Average value? The average value from, what does it say? From -2 to 5. So 1 over b minus a, integral from a to b of f of x dx. That's like the simplest thing. It's super important on the AP exam, though, average value. Because lots of times, okay, on the AP exam, they give you like a temperature of a function. They say, okay, this function tells you the temperature over so many days, whatever, and they ask you what is the average temperature. Average means average value. So you simply compute average value. I'm telling you, average value is a super important concept on the AP. Okay, I think you guys got it now, right? No, I think we got to review one more thing. I want you guys to score high. If I want you guys to score low, then we don't review anything. I don't. You guys are lucky. You guys even get the other classes. Do they even get practice tests? No. Okay, you want to show your love? Get the 5 on the AP exam. Otherwise, I'll come to your house and.
Wait, Mr.
Oh, I had a
Park,
night
you know
there.
this is
Mr.
recorded.
Park, what are you doing here?
This is recorded. This is recorded, Mr.
I don't
Park.
care. I'm gonna choke you. Okay, what was it? Oh yeah, length of curve. Find the length of the curve.
Mr. Park, wait.
Curve. Y equal. Okay, let me give you something that's gonna actually help you tomorrow. Then. Find the length of the curve. Y equal natural log secant x. X equals 0 to x equal 1. I can't believe I'm doing this. No, wait. No. That's too easy this way because you can actually do this by hand. I'm doing x cubed plus, give me a number.
7. Oh, 9. No, 27.
Too late, we're using 7. There, now you kind of, okay, this is good. Okay, what's the formula for length of curve that you guys keep forgetting?
The integral.
The integral from
A to B
0 to 1.
of the square root of 1 plus dy dx quantity squared.
Okay. So what do I put in the parentheses?
The derivative.
So you have to be able to take the derivative of that, okay? If you cannot take the derivative of that, the problem's over. So minus 6. Now, how do you take the derivative of natural log box?
1 over box times the derivative of
Okay.
box.
1 over box times the derivative of box. I'm gonna nail it. I'm gonna take a triple.
BT.
Boing. Is that a P or a D?
I was thinking P. Oh, there we go. The tension all.
Now, can you punch that in on your calculator? You think so? You think you can punch that in? You gotta be careful, you know. Here, I can't believe I'm telling you this. This is how you punch it on your calculator. I just want to separate the sheeps from the goats, that's why. So square root of 1 plus that thing, this gargantuan thing squared. Now what's the gargantuan thing? 3x squared divided by x cubed plus 7. But you got to put that in parentheses, sister. Then you got to close the parentheses, comma x, comma 0, comma 1. You know why you have to put this in parentheses? Because, okay, if you don't put this in parentheses, because I gave this problem last year and so many people got it wrong. If you don't put it in parentheses, your calculator does order of operations. It's going to do the division first, and then it's going to add the 7. So that's why you have to put that in parentheses. You know what I'm talking about? I can't believe I just told you that.
Yeah.
Well, I don't know what the answer is. Whatever. And make sure you give 3 decimal place accuracy. Don't guess. Love. Oh. Okay, I think we're ready for tomorrow. It's not hard. Tomorrow's test should be a grade booster. It should be.
It's gonna break your grades, so I'm gonna beat you for the year. I'm a win.
Oh, how come it's so blurry? How come yours so clear? Just stand by the board. I wanna see. Oh, it's still kind of blurry.